Hello and welcome to another day of Advent of Code. In day 5, we're dealing with lines and plotting points, and there's been a few similar problems to this in past Advent of Codes. So this actually, I had a very straightforward approach to this that I don't really have to think too much about. But I'm going to walk you through how I did my solution. So this is what the input looks like. And again, this is a problem where some people spend a lot of time on parsing. I'm going to show you how I approach the parsing, and that might help you out. But anyway, in part 1, we're going to be plotting all of the non-diagonal lines. So there will be 3 types of lines in this. One will be, I think this is a horizontal line. This one is a diagonal line. Do we have a vertical line somewhere? Yeah, this is a very small vertical line. Yeah, so you will see 3 different types of lines, ones that change in X, ones that change in Y, and ones that change in both, and they may be in either of the 45-degree angles. In part 1, we're going to plot all of the non-diagonal lines, and we're going to find all of the points which the lines cover at least or more than one time. And so we're basically going to be looking at all the squares that have a value greater than 1. And in part 2, we're going to do the same, except we're going to also plot the diagonal lines. Cool. So the way that I thought about this problem is I wanted a point space where I'm just going to plot the lines. This is kind of just the easiest way to think about this. I'm sure there's another solution where you do line intersection and figure out the points that way, and it's much faster. But I just went for the simplest thing that works, and so we're going to do that. And to represent my space, I kind of had 3 ideas for that. One is just use a dictionary where I plot the points in there. A better solution to that would have been a default dictionary where I don't have to check whether the point exists to increment it. I can just say that it's always starting at 0. Or I can use a specialized data set that's very specific to this problem, which is a counter. I guess it's not specific to this problem. It just works really well for this problem. So we're going to use a counter. A counter is basically a dictionary that maps to 0, but it has some other useful things like finding the most common values inside of it. I did a video on counter, so I will link that in the description. Points equals collections.Counter, and we're going to allocate things inside of this. We're actually going to use both the coordinates as the key here. So if we were to give this a type annotation, because MyPy is actually going to complain here, this is going to take a tuple int as its key. So we're going to have X and Y values as the key here. All right, so let's look over the input and parse it for line in input s.splitlines. And this is where we get to the parsing. So when I saw this parsing, I thought, okay, we're going to split apart these 2 chunks first, so then we can have numbers separately, and then we can parse based on the comma here. So we have point 1, or I guess start and end is equal to line.split, and we can split on this little string here, so we're just popping out the middle here. And then actually I called this x1s and y1s is equal to start.split on a comma, and x2s, y2s is similar, ends.split on a comma, and then x1, y1, x2, y2 equals int x1, y1, x2, and int y2. And so that should get us our points parsed to Python 3 t.py. Type object is not subscriptable. Oh yeah, right. I always forget to add my little feature import. One day I'll be working in Python 3.9 plus. This one is not defined. Oh, yeah, these need underscore s's on the end of them. Of course. That's what I get for recording in the morning. Just got out of bed. There we go. Okay, cool. So we're past the parsing part now. So now we need to figure out whether these are vertical or horizontal lines and then plot those points inside of this collection here. And basically to do that, if they're a vertical line, that means the x's are going to be equal. And if they're a horizontal line, that means the y's are going to be equal. And so we can say if x1 is equal to x2, that means we're dealing with a vertical line. So we're only going to be plotting across these points. Now, these lines could actually go up or they could go down. And so when I was trying to solve this, I got a little bit tripped up on that. And basically, I turned all lines that were going down into lines that were going up because they're equivalent. They're just in the other direction. And then the way I did that was by setting y it was from looping from the minimum value to the maximum value. So I did for y in range min y1 y2 and max y1 y2, and we have to actually add 1 here because we want to include the endpoint of our line. Range by default is non-inclusive because it's typically used for loops over a sequence. Okay, cool. Now that we have our y ranges, we can plot those points. We can say points, and we can pick either x1 or x2. It doesn't matter because they are equivalent here. And we're just going to say points plus equals 1. And we don't have to do any validation on whether this value already exists. That's kind of the magic of counter here. Now we're also going to do the same thing for our horizontal lines. And when I initially implemented this, I just did else because I didn't read the problem very closely and didn't realize there were diagonal lines. You can't do else here. You are actually going to have a hanging if chain that doesn't have an else. We're going to say elif y1 equals y2. So this is the case for horizontal. And we're actually going to write basically the same code as this here, except instead of y, we're going to use x for all of these. And then we're going to do points x. And again, you can pick y1 or y2 plus equals 1. This will plot all of our points. So after we run this, we will see that we get a counter that basically has positions, and some of those positions have the value 2, some of them have the value 1, and we don't really care about the zeros because we're not bothering to count those there. And so after we've plotted the points, we need to figure out how many of them are greater than 1. And now you could just count them here manually, or you could count them by looping over every value, or you can use a cool method on counters. Let's see. I just forget the name of the method. One sec. Is it most common? Yeah, so most common will sort the values by the most common values. And so we can basically loop over that until we see something that's not a 2 and increment a count each time. So we can say count equals 0 for kv in points dot most common if v is greater than 2, greater than 1, right? Then count plus equals 1. Otherwise, if we find a v that's equal to 1, we can just break out of this loop and we're done. And so at the end, we print the count. So that is how I solved part 1. Let's make sure that's correct. And it is. That is the value we expect. Cool. So that's part 1. Part 2, we have to handle the diagonals. And the diagonals are a little bit more complicated, but interestingly enough, we'll actually simplify the code after this. So I'm just going to leave this code alone. We're just going to modify it in place. You can, you know, if you want this for part 1, there you go. For the part 2, we have to handle the diagonal lines. And so there are well, I guess there's kind of 4 types of diagonal lines, like up, left, down, or up, right, down, left, up, left, down, right. But you don't have to consider them all in those cases. You can really just worry about which direction the x's and the y's have to change, and then do kind of a loop based on that. And so that was how I solved it. So we basically have 2 chunks of if statements here. Like if x1 is greater than x2, that means that x2 is actually going backwards. So we're moving the x to the left. So I said the x difference is, let's actually do this in the other direction. If x1 is less than x2, that means we're moving forward. So x difference is 1. Otherwise, we know that we're moving backwards. So x distance is -1, or x difference. And we do the same thing for y. If y1 is less than y2, then yd equals 1. Otherwise, yd is +1 or -1. Once we have that, we can basically make a loop over all of the positions of this line. So we can say xy equals x1, y1, while xy does not equal x2, y2. We're basically making a loop here. We can say points xy plus equals 1. Now, the way this loop works, we're actually We're actually not going to the end properly here. So we could either do it like this, where we do points x, y afterwards, which I think is a little bit clunky, or we can make this one further, xd and then yd. I think that works. I didn't actually do that in my solution, so we'll see how that goes. And then after that's basically it. So we've added diagonal lines here, and we should have the solution now. We clearly do not, because I forgot to increment the values. X plus xd, y plus yd. Now we get 12. Cool. Now, a really nifty thing that I noticed about this problem when I was implementing it in SQLite is this bit of code here can actually solve these parts too with a little teeny tiny change. So if we get rid of this part up here and we dedent this, it doesn't quite solve it right now. It actually loops forever because these are not fully diagonal lines. But we just have to add one more case in here. So if we do elif x1 is greater than x2, we have this. Otherwise, the difference is 0 because they are the same. That basically represents our vertical lines. And then we do the same thing here. Elif x y1 is greater than y2. Otherwise, yd equals 0. So now we have the three cases, the horizontal, vertical, and diagonal, all handled directly here. And you'll see we get the same solution. So I made this nice little simplification in my SQLite solution. But anyway, that's it. That's day 5. Hopefully you enjoyed, and I will see you around for the next day.